Hello guys, this is Sarkran from ITBHU and today we will be solving some problems. This is the integration section and basically many chapters are included between the lectures. So let's begin with the first problem. Uh, when I first saw this problem, I think it's a simple one, but little, no doubt it is a simple looking, no doubt. But yeah, when you will directly expand this problem, it will become too much lengthy and you will definitely do some silly error, right? And if not, then it will much time take. So what approach would I use to solve this problem? And very standard, basically, profiles were formed during the solving in my approach. So let's discuss my idea. What is my idea behind solving this problem? Okay, so let's begin. So first, what I do was my first step was I just take 0 to x ft dt is equals to gx, right? So what we can write g dash x basically is f of x. Let call it equation number one. Let call it equation number. Okay, let's substitute this value into the given equation. So what we can write x into g dash x plus gx equals something, right? And this is something we will write on the next page. Okay, so it is, in fact, we can write on this side also. E to the power x sin x plus x cos x and also plus sin x. Fine. Okay. Just observe this thing very carefully. What is the written on the LHS term, right? What is written? It is derivative of x gx. dx को क्रॉस मल्टीप्लाई अगर कर दें तो बेसिकली दिस जो फंक्शन आरएचएस में लिखा हुआ है इस फंक्शन को हमें इंटीग्रेट करना है, राइट? ओके, सो लेट्स फर्स्ट फोकस on how to integrate the function which is on the RHS side. Some people will definitely suggest to go with the bipart and something like that. But can you notice one thing? Can you notice one thing? Let's proceed with the integral first. Let's proceed with the integral. Okay. We have to integrate basically e raised to the power x. Let's multiply this e raised to the power x into corresponding terms. That is x sin x plus e raised to the power x into sin x plus x e raised to the power x into cos x. Didn't you feel? Here is sin x derivative cos x. Here is derivative of x we can imagine. Here is derivative of e to the power x we can imagine. So what we can think, if we take a function e raised to the power x into sin x, and if we differentiate this one time x will differentiate it, corresponding term is there, e to the power x into sin. One time sin x will be differentiated, cos x is there, and x to the power x will remain there. And e raised to the power x will differentiate and it is as same as that implies it is none other than the derivative of the function, that is x e raised to the power x into sin x. This is a very good observation. And let's proceed after this observation. Okay. So what we can write? D of gx is equals dx into d of x e raised to the power x into sin x divided by dx. Integrate. So we got gx equals x e raised to the power x into sin x plus c. Let's plug the value of gx. Gx is 0 to x ft dt. Sorry, there is a slight error. This is not gx, this is a xgx, right? There is a xgx. Okay, so there is a xgx and there is a yeah. Okay, so that is equals x e raised to the power x into sin x plus c. Fine. If you substitute x equals 0 on both sides, we got 0 equals 0 plus c. That implies c is 0. Fine. And then if we, it is 0. x got nullified. We got 0 to x ft dt equals e raised to the power x. If you can erase this stuff also, bear with me. Okay, e raised to the power x. This equation. Let's differentiate this once more. Differentiate fx equals e raised to the power x as it is into sin x plus e raised to the power x into cos x. Fine. हमें वैनिश के नंबर ऑफ रूट्स निकालने हैं, राइट? That implies e raised to the power x into sin x plus cos x equals 0. That implies tan x equals minus. Let's check. As we all know, tan x is a periodic function, right? In the interval 0 to pi. Basically, pi is the period, right? So we have to calculate minus 2024 pi to 2024 pi, right? Clearly, 4048 basically will be the intervals of 0 to pi type. 0 to pi type. So, in corresponding to 0 to pi, there's only one solution. So, the answer will be 4048. Okay. I hope you love this problem. This is a very amazing manipulation and a very important observation to solve this problem in the few steps, no doubt. So let's proceed. And thank you guys.